So I'd like to ask if maybe if you could share with us one or two of the key findings of the research that you were speaking from this morning.
What I was trying to focus on was that children try to understand the world. They act on the world, they move things around, and they ought to learn to use numbers to represent what they think. So if they can use numbers as a representation for thinking about the world, numbers come in as a form of representation. So they don't have primacy over the reasoning. They come in to support the reasoning. The difficulty with this is that numbers have two meanings. They have this representational meaning, and they have a meaning which is defined by the number system. And if we just focus on the meaning that is defined by the number system, then children don't learn to use numbers as tools for thinking. They're just thinking about the numbers rather than using numbers to represent what they think. And I think that's a tension, because they have to learn both meanings of number, but the primacy should be given to the children's thinking and taking numbers as a tool for thinking about the world.
Nice, yeah.
Well, I think the way it informs early childhood education is that we have to think about symbols more broadly. When a child tries to represent something numerically, it doesn't matter whether it's a number word or a digit, or the child actually puts 3 fingers up. What the child is trying to do is preserve the information about quantity. And if the information about quantity is preserved, then the child can operate on that representation of the quantity. Then that symbol is serving the child's reasoning. Now, all of us at some point might actually want more concrete representations to be able to think about a situation, even though we know how to use number words or symbolic, digits on paper. We might sometimes want to represent things more concretely to be able to think about them. We shouldn't think that the children have to discard any kinds of symbols. The important thing is if the symbol preserves the quantitative information and the child can operate on that quantitative information, then the symbol is supporting the child's quantitative reasoning.
So it's a valuing a multiplicity of ways of representing their reasoning, as opposed to just making it go down a narrow school thinking kind of a path.
Yeah, and particularly, there is, I don't know here, but there is in England this idea that we ought to get the children to stop using fingers.
Yes.
And why?
Yes, yes.
They're with them all the time.
Yes.
Yeah.
Yes.
Whatever symbol preserves the quantitative information and you're able to manipulate, that's what helps your quantitative reasoning. Education is a conservative business, isn't it? We think we are very well educated, so we would like people to be educated the way we were.
Yes.
And that's what I think is a very strong challenge, because we have to think about other better ways of making use of children's reasoning, which we haven't recognized yet. And I think the example that always brings this to mind for me is the idea of multiplication, and that's why I was talking about it today. Because the research has shown, and it is for 20 years already, there is clear documentation that children who are 5 and 6 are able to solve multiplicative reasoning problems, both multiplication and division problems. But in school, we have preserved a tradition that says first teach addition, and then subtraction, and then multiplication, and then division. So we are not making the best use of children's reasoning about situations that they can understand, and we really could be using that reasoning at a much earlier age. this is one of the things that I find a big challenge is policy has focused on children, teaching children about number. And that's teaching the representation. But what about teaching children about quantity, which is the meaning of numbers?
Wow.
So if we were to say, okay, the real challenge here is to think about a curriculum that helps children understand about quantities, relations between quantities, and how to represent these numerically, the focus would change entirely.
Yeah.
Well, the exciting thing about this is that I think early childhood educators would be much more comfortable with mathematics.
Oh.
Because they can actually see the relations between quantities, you know. So they would feel like, oh, this I understand. And if numbers come in as a representation of something we understand, then we are much more comfortable. Now, here's the real question to pose to curriculum developers. Why do we need different kinds of numbers? We need whole numbers and rational numbers. Why? Because they represent different kinds of quantities. The number structure mirrors the organization of relations between quantities. So that's a really different way of thinking about the curriculum. But that would be a fascinating way of making everybody more comfortable with mathematics, I think. I hope.
So I totally hear you. I think then, because if it gets about making sense, then everybody can relax, because it's about making sense, right?
Making sense and being comfortable, as I noticed how many reactions we had to your talk that were emotional. And it does, it touches us somewhere deep inside when we, as you say, have a way of being more comfortable with the mathematics.
Yeah. Let me give you an example of something most teachers hate. And we had a teacher say to us, she once started teaching about fractions, and they all ended crying. The children in the classroom all ended up crying because the children kept saying, I don't understand this, miss. And she said, neither do I. Now, what do we do when we teach fractions? We try to use whole numbers as a transition to how you write fractions. But actually, fractions are required because we need to represent things that whole numbers don't represent. So we have to start by thinking, what is different about these quantities that we want to represent? And if we start there, because fractions are created not by counting and adding another one, but by dividing. So if we start thinking about fractions as born out of the logic of division, then you can see 6-year-olds telling you that the bigger the number of children receiving something, the less each one receives. So if they actually learn to represent, for example, 1/3 as 1 divided by 3 and 1/5 as 1 divided by 5, and you say, which one represents more? They will tell you, well, if you give to 3, each one's going to get more than if you give the same one to 5. So if you actually, instead of covering up the change in the conception of quantities that they have to make, and say, start from that and say, okay, these are numbers that come from division, not from counting. So let's start with the logic of division. They feel entirely different about what fractions mean. And that's why I was saying to you, yesterday we were having the session walking on fractions with children, and these children said to us, I don't want to go to the classroom, they're doing math. And this is so interesting. And they were doing fractions.
They were fractions.